in 24 large vessels called reactors that were arranged in groups of 4. Inside each vessel, thousands of pounds of highly flammable, toxic vinyl chloride reacted under heat and pressure to form PVC. An operator controlled the process from a panel on the upper level. When the process was finished, a second operator would walk down the stairs and open valves on the reactor piping to transfer the product out. After completing the transfer, a worker back on the top level would then clean out the inside of the reactor with a high-pressure water blaster. The worker would then go to the lower level and open the reactor bottom valve as well as the drain valve. Water emptied onto the floor into a drain. On the evening of the accident, an operator started cleaning reactor 306 with the water blaster. He then walked downstairs to drain the water out of the reactor that he had been cleaning. But he made a critical mistake. The CSB concluded that instead of turning left at the bottom of the stairs to get to reactor 306, the operator turned right to a different group of reactors and approached reactor 310. But reactor 310 was not in the cleaning process. It was pressurized and heated in mid-cycle, making PVC. The operator turned switches to open the reactor bottom valve and the drain valve. The drain valve opened, but the reactor bottom valve remained shut. An interlock blocked the air supply to the valve's actuator. It was designed to do this as a safety measure when the reactor was under pressure, to prevent an accidental release. But instead of checking to see why this valve would not open, the operator decided to bypass the interlock. He disconnected the existing valve air supply hose and reached for one with a continuous air supply meant for use only in emergencies. He connected this hose to the valve. It opened. Suddenly, the highly flammable vinyl chloride mixture began rushing out onto the floor, producing a loud rumbling noise that sounded to witnesses like a jet engine. Workers smelled vinyl chloride, and the vapors triggered an alarm. The shift supervisor rushed toward the reactors. There he saw reactor 310 spraying vinyl chloride onto the floor, where there was already a foaming mixture 1.5 feet deep. Believing he could stop the release, the supervisor raced to the upper level and told operators to open valves, which would relieve pressure in the reactor. The supervisor and one operator then tried to get to the lower level through an interior stairwell, but were stopped by the overwhelming odor of the vinyl chloride vapor. The operator remained on the upper level. The supervisor headed down to the lower level on an exterior stairwell. Just then, the vinyl chloride ignited and exploded violently. Witnesses reported 3 or 4 additional explosions. 4 workers were killed immediately. The 2 operators who had been working at the top of the reactor, and 2 operators who had been on the lower level, including the one who had apparently opened the reactor bottom valve. A 5th operator, who was seriously burned, died 2 weeks later. 2 other workers and the supervisor, who had been in the exterior stairwell, were seriously injured. The force of the explosions destroyed much of the plant, including the laboratory and the safety and engineering offices. It blew off the reactor building roof, knocked down walls, damaged